Alright, this is examples 3 and 4 of L'Hopital's rule. Okay, so example 3, you're actually going to do it more than once. Okay, so here, first you want to verify that you can use it. X goes to negative infinity of x squared. Negative infinity of x squared is positive infinity. And limit as x goes to negative infinity of e to the negative x. So if I plug in negative infinity to negative, so that turns into positive infinity. So that means it's going to positive infinity. Right? The new exponent is going to positive infinity if it's the opposite of negative infinity. So e going to, with the exponent going to positive infinity, e to the x is going to positive infinity. Right? E to the exponent, whatever. All right. I hope you understood that because I know I just did a lousy job. All right. But I have shown that they're both going to infinity, so that means I can apply L'Hopital's rule. So derivative of x squared is 2x. The denominator is negative e to the negative x. And I do it again. Limit as x goes to negative infinity. 2x is negative infinity. Limit as x goes to negative infinity. Negative e to the negative x. So the e to the negative x is positive infinity. But I put a negative on it, now it's negative infinity. So I have negative infinity over negative infinity, which is fine for L'Hopital's rule. Okay? So I take the derivative again. Derivative of 2x is 2. Derivative of that is positive e to the negative x. Alright, so now the denominator is going to positive infinity and the numerator is staying constant. So that means the limit is 0. So remember, when the numerator stays constant, but the denominator is going to infinity, the limit of the ratio is 0. Okay, example 4. Now, this is an integer form that we have not discussed, so we'll do that. Hopefully, I would remember to do that in class. Alright, so I have the form 0 and infinity. So what do you do with that? Well, L'Hopital's rule does not apply, so that means you got to change it. Okay, so what I want to do, e to the negative x like that. So that's e to the negative x. That's what's going to 0. If x goes to infinity, then e to the negative x. That's like that whole denominator is going to infinity, the numerator is staying constant. Okay, and then the square root of x, as x goes to infinity, square root of x goes to infinity. So that's the 0, and that's the infinity. Now this part you don't have to show. It's in your benefit to show so that you know what you're doing. Okay, but I'm being lazy because I'm not using L'Hopital's rule yet. All I want to do is rewrite this. All right, it's a negative exponent. So I'm going to put in the denominator, the positive exponent. Now look, as x goes to infinity, now I can do the whole limit thing. Limit as x goes to infinity. The square root of x is infinity. And the limit as x goes to infinity of e to the x is infinity. So now I have infinity over infinity. So now you apply L'Hopital's rule. And L'Hopital's rule says I take the derivative. Derivative square root of x is 1 over 2 root x. And derivative of e to the x is e to the x. And here, I'm going to just clean up using some algebra. So I'm not using L'Hopital's rule here. So it's 1 over 2 e to the x root x. So I basically just took that fraction in the numerator and then brought it down to the denominator. Okay? So now I have everything in the denominator, and that's going to infinity, so the whole thing is going to infinity. I'm sorry. Since the denominator is going to infinity and the numerator is staying constant, it's going to 0. And that's example 4.